Hello, everyone, and welcome to this live stream. So I'm Alistair. I'm developer advocate at Tinybird, and I've got Jorge Sancha, who is CEO and co-founder of Tinybird, with me.
Hello, everybody.
On mute while his dog goes crazy in the background. Now, we are going to take you through turning Kafka streams into REST APIs with the purpose of powering visualizations in an app. We're going to use energy generation analysis as the use case for this. So we want to expose this data to our users through some visualizations. We have built a dashboard using Next.js and Tremor to do this. So Tremor is a visualization library for React that comes with a bunch of beautiful pre-built components and layouts. So stupid easy to throw together a great looking dashboard. Now, this is a web-based dashboard, so naturally you'd expect that you get the data via a REST API over HTTP, and it's probably in JSON. That's pretty much the standard. But we're not limited to just building for the web. So HTTP, JSON, pretty universal. So every language tool out there can use it. So we could reuse this same approach, whether you're using something like Streamlit or Retool or any other visualization library, really. So pairing this kind of application directly from Kafka is not really possible. At least it's very difficult. Kafka is a great message bus, but it's not really designed to have a lot of our end users coming to it and asking for a particular slice of data. So often what you end up with is folks having some kind of batch ETL tool. And that runs on a schedule, say every hour, pulls the last hour of data out of Kafka, dumps it into something like Postgres. And then they write an API, maybe using something like Node.js Fast API to handle incoming user requests. And then you have some form of ORM layer, which translates that request into SQL and pulls the data from Postgres or another database and returns that to the user. Now, doing this, you've got Kafka, an ETL tool, Postgres, your ORM and API layer, plus your application. So you've got 5 moving pieces to stitch together to build your application. And now you don't just need to make that functional, you've then got to scale it, you've got to secure it, you've got to update it. And inevitably in the future, at some point, you are going to want to add new features, right? And every time you want to do one of those things, you've got 5 pieces of the puzzle to go and update. So having so many moving pieces just adds a lot
Sorry.
It's okay. It's going to be a constant mascot throughout this.
I'm very quiet because my dog is freaking out in the background. I'll speak some more later. I'm sorry.
So with all of those moving pieces, we've got a lot of complexity. And as we all know, complexity is basically time and cost. So we want to show you an alternative way to build that very back end, but cutting out all of those moving pieces and just having a single tool between our Kafka and our application. So we'll show you how to build those APIs to power your application using Tinybird. Now, all of the code for the demo that we'll go through is on GitHub. So the GitHub URL is streaming across the bottom of the screen, so feel free to go and check that out. In this stream, I'm going to build everything through the Tinybird UI, but if you go and check out the GitHub repo, the README and the instructions in there use the Tinybird CLI. So everything we do can also be done through the CLI, can be done programmatically, and the README has all of the steps of how to clone the repo and use the CLI to push that up to Tinybird rather than building it manually through the UI. But I'll do it in the UI for the demo, as it's a bit more, fun to watch. Cool. So
I'm being a super bad wingman here, but I'm conscious there's workers in the house and my dog is like freaking out. I'm sorry.
I'll just have some amusing banter with myself. It's okay. So let's quickly run through what we're going to build and what's in that Git repo. So this is a very basic diagram, and it's in the Git repo if you want it as a reference. But basically, on the left, we start with a Python data generator, and this is just so that we're faking a stream coming into Kafka. And this is just a really sort of hacky piece of Python, which is hitting the UK's national grid APIs. So the UK's national grid is the body that manages all of the infrastructure to supply energy in the UK. And them and a group of other people have built these what's called the carbon intensity APIs, which gives access to some data about power generation. So the Python script is just hitting that API and pulling some data down. The data is not very granular, so they only give about every 30 minutes. So that wouldn't be that much data. So the generator is pulling every 30-minute bucket and then generating synthetic data between the 30 minutes just to increase the volume of data and the granularity. From that API, we get two sources of data. So we've got the intensity data, which is the intensity of carbon emissions from the current power generation. And then we've also got the generation stream, which is the mix of sources that are generating power at the current point in time. So once we've got that data, we are sending that from Python to Kafka. And we've got two topics in Kafka, which is intensity and generation for the two streams. For this demo, I'm going to use Confident Cloud as my Kafka, but just as an FYI, pretty much anything that walks and talks like Kafka, so presents a normal Kafka client, works with Tinybird. So you might have the free open source Apache Kafka, self-hosted on-prem in the cloud. It might be AWS MSK, managed Kafka. Confluent, Kafka on-prem cloud, Avon for Kafka, Red Panda, Apache Pulsar with the Kafka compatibility layer on top, including Stream Native. The Cloudera's on-prem or Cloud Kafka, and Upstash's serverless Kafka, or anyone else that is providing Kafka services, they all work. So on the other side of Kafka, we'll sync our stream into Tinybird. So in Tinybird, we're going to analyze our data and publish the REST APIs. So to build REST APIs in Tinybird, all we need to do is write SQL. We can filter, aggregate, transform, join any other SQL word into the shape that we want to expose to our users, and then pick which SQL query we want to publish as a REST API. You don't need to write any of that API or ORM code yourself. You just write the SQL queries, and all of the security, the scaling, and the upgrades all handled for you. So you just focus on building the features that you need for your application. Lastly, the APIs we build in Tinybird will be consumed by our dashboard app. And as I said before, that's built using Next.js and Tremor. So we can quickly take a look at the dashboard without any data. So the wheels are going to spin because the APIs don't exist. And you can see that at the top, we've got our section for our generation data. Below that, we've got our carbon intensity and our carbon intensity forecast accuracy. So the carbon intensity data also comes with a prediction, essentially a forecast of what the carbon emissions will be. And it's actually quite interesting if you go and take a look at the carbon intensity API page. They use some interesting ML models to try and predict this stuff in the future. So at the bottom, we'll try and show a time series of the accuracy of those predictions. So in this dashboard, we've got different styles of data. We've got some time series at the top. We'll have a little pie chart and some metrics here. And yeah, I mean, generally just a mix of time series and various different metrics using the various different components and widgets in the Tremor library.
And this is available in the repo as well.
Yes.
If you want to see exactly how it's built.
Yeah, correct. And there's a link to this live demo in there as well, which is hosted on Vercel. But obviously, you can go away and clone the repo, run it locally, deploy it into Vercel, whatever you want to do. Cool. So anything you want to add, Sancho, or I'll kick into the demo.
No, I think we should start. Seems that things are calming down here, so I'll chip in as you go along.
Okie dokie. Right. So in Confluent Cloud, I have two topics created. I'm not going to go too much into like setting up Kafka or anything. I'm just going to assume you've got Kafka, and we're taking it from there. So we've got two topics set up, which is generation and intensity, and we'll be sending data into those. I've preloaded these with about 4 million messages that cover the time period of about middle of 2018 to the start of December of this year, and then later on I will live generate the rest of December's data, but these topics are already preloaded at the moment. So we've got those two topics and we'll connect those. The other thing we need is API keys. So I've already generated some credentials that I'll need. And we'll also need our broker list as well, which is from the cluster settings Bootstrap server. So to kick off, we'll come over into the Tinybird UI. And to connect our Kafka, we can go to the data sources on the left and hit the little plus. And that'll open our little data source modal. And we can click onto the Kafka tab and we'll see our window to create a new Kafka connection. So it's the Bootstrap server, the key and the secret we just talked about, and a name for the connection. There is also the option to have messages decoded with the schema registry if you do use a schema registry. So I'll copy and paste my details in. And obviously I am showing the credentials on this, so I will invalidate them afterwards, but it's only a demo cluster, so I'm not too worried about it.
I think it's worth also mentioning that we're using this in the UI now and creating the connection, but these the creation of the connection can also be automated via the CLI, so that if you, as part of some deployment into another environment, you need to create the connection into another workspace, that can also be automated, which it becomes in handy when you're thinking about how to deploy to production.
Yeah, and steps to do that are in the README of the repo in GitHub, if you're interested in checking that out. So with the credentials and the Bootstrap servers in, I have set the name to demo, and I'm just going to hit connect. So that goes away and it's connected, and LastPass can go away. And it shows me my list of topics. So I'm going to start by connecting the intensity topic. It auto-generates a consumer group name based on the timestamp. You can change that if you want to. I'll just leave it as the auto-generated one and hit continue. And it's going to go away and get a sample of the data to try and work out the schema. So it's inferred the schema, and obviously if you have the schema registry, you can use that to inform it. And it's worked out that these are ints. This is a string. These two fields date times. Optionally, it's also showing me the raw value, which is not selected by default. If you want to preserve the actual raw message, you can. It's generally not advisable unless you have a good reason for it, but it's there if you need it. So we can go and change the column names if we want to. If we want to change these, and we can change the types. So for example, this intensity index, I know is very low cardinality, so it only has 3 possible values of low, medium, and high. So I'm going to change that and turn that into a low cardinality string, which is just significantly more efficient than storing all of the raw strings. So I'll also set the consumer offset to earliest, so that it's going to go and find what all of the messages that exist in the topic today and consume all of them. It's not just going to find what the latest committed offset is and start from there. So I'll tick earliest. I'm not going to apply TTL because I don't want to TTL my data at this point. But if you do have data coming in and you don't actually want to store all of the historical data for all time, you can apply a TTL to say, based on this timestamp, only keep data for 7 days or a day or 30 days or whatever you want. I'll also modify the name and call this intensity. So with that, I will hit create data source, and that will add my data source. And that's going to go and start consuming all of the messages out of that Kafka topic. So there's about 4 million in there that'll go and consume those. And that's one of my streams. So that's all I have to do to add my first Kafka topic. And I'll just do basically the same thing. Add a new data source, go to Kafka, and it's saved my connection details. So I don't have to set that up again. I can just hit choose topic, select generation, hit continue. And it's inferred my schema. And I'm not going to change any of these. So that all looks fine. I'll set that one to alias. Again, I don't want TTL. And I will rename this to generation and hit create data source. So that's Kafka connected. That took 2 minutes of me sort of waffling on around it. But we've got our 2 topics. We've got our intensity data, and that's ingested about 3 million rows already, and our generation data. The intensity one, the topic is a lot more dense. There's a lot more data in the intensity topic than there is in generation. So that's Kafka connected, and we've got our data, so we can actually start writing our SQL to start doing something interesting with this data. I'm going to start building these pipes, and I'll sort of talk through them, but Sancho, feel free to jump in and do the interlude music while I'm typing, so that there's not just boring silence.
One thing to bear in mind is that this, you can go ahead, Alistair, but one thing to bear in mind is that as data is being ingested, it's immediately available to query. So that makes it, very, it makes Tinybird ideal for when you want to exploit that data as soon as it's being generated. So you can be consuming from the topics and creating APIs on top immediately, and that's really relevant for Tinybird and for those use cases where you need to work over fresh data.
Yeah. So just to quickly explain what I'm doing. So I've created a new pipe over here on the right by hitting the plus. And I've set its name, so this is going to be the generation mix API. And I'm going to set a description in here so that I can document my API as I go. And you can use Markdown syntax in this description to start doing some pretty documentation on your APIs. Once we publish this as an API, you'll get an auto-generated documentation page, which you can share. So you'll have a Tinybird formatted one, but then we also generate OpenAPI 3.0 specs, which you can share in your team as well. So for example, I can document one of the parameters, and I'm going to have a from parameter in here. So I'll just call it param from, and I'll have one called param2, so that I can give a date range and say, from here to there to supply date range, for example, and it goes away and formats it. So when we actually start writing our SQL, it's in our pipe, but then within our pipe we have nodes, and nodes are just a container for individual select statements. So I can run the default just select star, and it goes away and gives me a preview of that data. For this one, I don't actually want to query the intensity table. This is the generation mix, so I want to query generation. I'll run that, get preview, and if I click on the name of the table, I can get a side pop-up of my table so that I can see what my fields are. So that's really helpful while I'm sort of exploring my data. So instead of doing select star, because I don't care about any of these Kafka fields, I'm going to list out the columns that I want.
We'll talk about these meta columns later in the context of observability. And I'm going to give you a trick that I don't know if you know, Alistair, but if you write all columns like the word all columns, it's going to fill in all the columns for you, and then you can get rid of the ones that you can try it in the next one.
Today I learned.
That's like a nice Easter egg in our autocomplete.
Yeah, I didn't know that one, but I've got some extra columns that I'm going to add to this one, so I'll avoid that one for now. So I'm just going to select the columns for all of the different types of generation and the times. So I've got a time from, which is the time window that this data started at, and the time window that it ended at, because these are 30. What is it? Was it 1 second granularity on these? I think. No, this is the generation, so it's 30 minutes granularity on generation. So we've got time from, time to, coal, gas, hydro. We'll do our clean energies, solar, wind. We've got other, which who knows what that is. Imports, nuclear, and biomass is in there.
So Achilles is asking a question. So keep going, and I'll start answering. He says, "Hey guys, minor question: how are duplicate messages handled by Tinybird on the Kafka consumer side? Are they omitted, or do you need to manually handle these?" So they are, the duplication for it requires a strategy. You need to think about, depending on what you're trying to do, you might want to use one strategy or other. It doesn't happen automatically. We are simply ingesting messages, and as long as they have a different key, we ingest them. And then what if the data is duplicated because you're, for instance, if it's a transaction that changes state, and you get the new the same transaction every time with a different state, and you want to keep the last one, then you need to have a sort of a duplication strategy, which can be either using some of the functionality that ClickHouse provides to do that, which is, it could be one of the engines. Although that doesn't solve the entire problem, you still need to bear in mind how to deal with that. Or you can be doing in your SQL the queries that are taking into account that there might be duplicated data, and you just want to keep the last one. We have a great guide that I'm going to point to. I'm going to link in the chat here, that talks about how to the different deduplication strategies that are useful to know. So I'm just going to I just pasted it there for reference.
Cool, thanks for that, Sancha. And just to explain what's going on screen, so I've selected all my columns, which is the individual values for what percentage of generated power was coal, was gas, etc. But then I've also done just added them together, so the total of coal and gas percentage is how much of was fossil fuel, and then added hydro, solar, wind together as renewables, etc. And that comes through as this really awkward, really long float, so I don't really need that level of precision, so I'm just going to chop off some of that and turn that into a slightly more efficient type, as I don't need it to be that accurate. So I'm going to cast it into a float 32, and then I am going to floor. To make that into a slightly nicer number. And I'm lazy, so I'm not going to type that out again. I am going to copy and paste. And just hope that I don't make any copy and paste errors.
There you go.
Cool. So we've turned those awkward numbers into float 32s, the same as every other field, with a single level of precision. So we're just selecting every single row in here. We're not doing any aggregation or anything like that. We're not doing any filtering. We're just selecting what we want and sort of transforming it a bit and adding some new columns. So I'm going to close this because I don't need that anymore. I've got all the columns that I want to work with. And now when I do this in my dashboard, if I quickly flip back to the dashboard, we've got a time selector, so I can pick, sort of today and last 7 days and the time range, and that's going to come through as a begin time and an end time. So I need to be able to take in 2 parameters on my URL to say, give me data between a start date and an end date. So I'm going to just add that as a normal where clause to my query. So I'll do, where time from is greater than a to date on a string. Let's start with this and say 2020 01 01, and time 2 is less than due date of 2020 01 02. So just a standard where, but actually I don't want to hard code these values. I want those to be user parameters. So we'll start using Tinybird's templating language to start adding variable fields and sections into our query. So the interesting thing when you're doing templating of queries, where you may or may not have items in your where, is, the first clause in your where doesn't have an and all the subsequent fields do have ands, so it can get quite tricky sometimes in logic to work out where ands are supposed to be. So the little trick for that is just stick a 1 there, and then always supply and to your variable clauses. So the templating in Tinybird is, I don't know whether it still is, but was originally at least inspired by the Tornado templating language in Python. So if you're ever in doubt, think Python. So it uses the mustache syntax of Tornado. So I'll add a little templating block, which is the squiggly brace and % sign. And here is where I want to do my, time from is greater than or equal to, actually, my start date, which is going to be a parameter. So I'm going to use the mustache syntax here, which is 2 squiggly braces, which denotes an incoming parameter. And this is going to be a date. And I'm going to call it, what did I call it at the top? I call it param from. I'll give it a default of, what did I use down there? 2020 01 01. I can give it a description, say the date to start from. You can come up with something more inventive. And this is a required field. So that's now a parameter in my query that's going to come in as a URL query parameter on the request, and I'll show you how that adds in a second.
But one question: do you, those first keys? I think you don't need those. You just need the ones for the brackets. I mean.
Yeah. Well, this is because I meant to do an if.
That's what I was thinking.
Yeah. Good catch.
Okay.
That always happens. So the reason I was adding this bit is to do a if defined, which I want this over here.
That's right.
So I only want to actually add this and to my query if this parameter has been defined. So if the user has defined param from, then I'm going to add this and block. And good catch on that one. That would have been an annoying one to have gone forward with, try and work out what I was doing wrong there. Always happens when you're doing a live demo.
I was feeling like maybe this is something new I don't know about.
This is the advanced Tinybird usage that you haven't learned yet.
Exactly.
So that's my starting date, and then I want to do exactly the same thing for an end date. So I'm just going to copy and paste that and turn that into param2, and turn that into a less than equals to, turn that into 2, and put the default to that, and change the description from to end at.
And you also need to change the and time from. The second one is time to.
So many to change. There you go. Right. So that is now 2 optional clauses in our where to say only select the rows of data between a start date and an end date, and the value of those is going to be supplied by the user when they hit the API as part of the URL. So now that I've hit run over here, the query runs, but if I go up to the top, it's detected that there's 2 dynamic parameters in my query of type date called param from and param2. And I'll show you how those get referenced in the docs in a moment. So this is my my time series data. So if I go back to this dashboard, I had my time series block over here to show the mix of generation over time at the top. And then beneath that, I had just the metrics to where I want to show what the latest values are. So I want to say, what was there'll be a pie chart here in this empty box. What was the distribution of generation for the very latest time? So I'm going to add another block to this query where I don't want time series data. And I'm going to have another parameter called latest to get the just the latest data. And I will say if the latest parameter is defined and latest is equal to true. And I'll close my if before I forget. I will order it. In fact, I don't really need to order it for the latest, so I'm only returning. Well, I'll order it because then it's then I can just do a limit 1 and get the very latest. So I'll order it by the time from descending, so the latest one's at the top, and then do a limit 1. And that will just get me the very latest value for the generation mix. And actually, I don't want to end it there. I want to do an else there and then end it afterwards. And here, I want to do an order by the time from ascending, so that when I don't give the latest and I'm actually getting the time series data, I order it with the earliest at the top and the latest last. Now what syntax have I broken?
Oh, is it syntax error? Time from limit. I think see. It all looks pretty good. I don't know what doesn't it like.
script. Is this?
There you go.
No,
yeah.
It's happy. It's just the logic of not having parameters.
I think it was probably detecting the making a mistake of getting the limit.
Wait. No, I do have an end. I thought it was going to be a missing end there, but I did put that in earlier, didn't I? Because I thought I was going to miss it.
Yeah. Anyway, I think it's okay.
I'm going to publish it and test that with my parameters in there. So I'm going to call this node endpoint. Oh, I can't because it's going to.
But it was working with when you set the latest, no?
Yeah.
Okay, yeah. But then you can pass it around. I would try to turn them around. I think it's getting confused with limit
no.
one.
No, in
order by
in the chat. Yeah, I missed the by.
And Echo, thank you very much. There you go.
Thank you. Right, endpoint. Right, so I'm going to call this node endpoint. Thank you very much for saving my bacon there. So I'm going to call that node endpoint, and I'm pretty much finished with this query, right? So I can get a time series set of data by providing the param from and param2. And then if I just want to get the very latest value, I can set the latest parameter to true, and I just get one result. So to publish that as a HTTP API, I can just go up to this little button over here in the top right, create API endpoint, and pick my endpoint node, hit publish, and that publishes as an HTTP API. So at the top here, I get some little observability into my API, and we'll go into it later, but you can actually get into the raw logs of your API and build your own pipes and analysis over the observability data, but you also just get a little visualization here on the docs page for it as well. The params come through with their types, their defaults, and the descriptions, and we get a little sample of usage here. So we get snippets just as the HTTP URL, a JavaScript snippet of how to use it, curl, Python, and all of the APIs are actually available in JSON, CSV, NDJSON, and Parquet. So to get the different types, you just change the generation mix API .json, you turn that into a .csv, and you'll get it in CSV, and same for NDJSON and Parquet. So you get all of those types. So we also generate the Swagger, the OpenAPI 3.0 spec, and then we also generate a Swagger page for you as well to share those documentation pages. So now that I've published that API, you can see here, like if I copy this URL and paste that into my browser, I get a JSON response, which I probably need to zoom in for that actually to be readable. But we get the meta, which is like all of the columns and types that will be included in the data, and then an array of all of the rows. So I'll close that, and I will come back to my dashboard. Boom. And as you can see, boom, it all those APIs now exist. It's hit the API, and it has gone and got the data and started visualizing it. And we've not done anything special with this dashboard. This is just all out of the box Tremor stuff, and it looks amazing. Yeah, as we start.
Yeah, I was going to say a couple of things that worth mentioning is if you can show the developer tools just to show, you change there's other failures there because of the APIs that are missing.
The other APIs exist, yeah.
Exactly, but if you filter by generation mix or whatever the name is, in in at the top where the filter icon is. But
yeah, it's here. This is the
yeah,
generation mix API call here.
yeah. So that's I think really interesting to see also that the response time is super fast. And this leads me to the other thing, which is one of the key things to understand with Tinybird is that not only we can ingest the data at scale, but also we host the APIs at scale. So you can build directly on top of these APIs without having to set up a specific infrastructure for it and or security for it. You know, we bring that into the mix as well.
Yeah. Yeah. So every time we refresh this, every time we change like the time window and all of that, that's all hitting the API and getting live data. So you'll see later on when I start ingesting December's data, I'll be refreshing this page and you'll see it pick up the very latest data. Cool. So that's API 1 down. Now the next API is going to be very similar. So this is going to be the carbon intensity data. So now that we've finished this one, we'll move on to doing the carbon intensity, which is going to be very similar in that we're going to have a time series piece of the API, which can fill out this time series chart, and then the metrics to say what is the very latest one. We'll block that out. So I'll just like type away on that. There's not going to be anything particularly exciting in the SQL to explain for that one. There'll be something slightly more interesting for the forecast accuracy one. But
yeah, I was going to suggest, in the interest of time, you know, maybe if there's copying and pasting and then explaining the SQL is probably.
Yes, I can do that. We're at 42 minutes already. That is surprising. Although it does break the fourth wall to go and copy and paste the queries and say, hey, look, we actually prepared for this live stream and went and built this all before. But I mean, maybe I've already broken that fourth wall because it's all in the Git repo. So yeah, I'll just this is the Git repo. I've just cloned the Git repo, and this is it open in VS Code, so I can go over to the endpoints, and I want the API intensity API pipe here. I'm just going to go and copy that SQL, and I will paste that in.
Yeah, and we'll talk about the CLI later as well. That essentially, if you wanted to start the project from scratch, you could just push the project into Tinybird, and you'd get all of these queries out of the box. But obviously, we wanted to show how this is normally built.
Yeah. So there's nothing particularly exciting in this API from compared to the last one. It's very similar. So we are just computing averages of the intensity and bucketing it by 15 minutes. So we do it using the toStart 15 minutes function on the time from, and then grouping it by that time. So it comes in 15-minute granularity.
I think it's because that's not that one.
There you go. It's because of the indentation. Yeah. So I'll rename this to endpoint as well. You don't technically need to name them endpoint. I just do that as a way to know which one I'm publishing as an endpoint. That's not strictly required. So with that published, it's exactly the same. We take a from and a to time range, and it has the latest parameter and does exactly the same thing. Gives us a time series or the latest. I'll publish that as an API. We get the exact same thing. If I go back to my dashboard, this now fills in, and we start getting all of the data for that. We've also got this nice little ticker here, and that's really just because we wanted to try the ticker component out rather than more so than anything. We just wanted to try that component out because it was cool, which just shows whether the forecast was above or below what the actual value was. So the last one is the interesting one to talk through because we're going to use a materialized view to power this one. So the amount of data we could return at the second granularity that we have is probably too granular for it to be that useful. Like, you don't need to see it on the per second when you're just looking at the accuracy. And obviously because if you return millions of rows to a user's browser, their browser's just going to fall over. So really what we can do is to do an average over a time period and then change how much the window that we bucket that data by based on the time range that user selects. So if the user wants to see a week's worth of data, we can give them, or less than a week, we can give them slightly more granular data because we're not returning a massive time period. So we could dynamically say, hey, if the user wants, up to 7 days worth of data, we can aggregate this by hour and give them an hourly time series. But if they want more than a week, they're asking for a massive time period. We don't want to overload their browser, so let's aggregate it by day. And then if they ask for a year's worth of data, we're only giving them per day rather than per hour. So we'll use and the other reason to use a materialized view is last year's averages aren't going to change, right? So last year has already happened. We're not going to go and update that average again. So there's no point recomputing it at query time every single time. So we'll turn it into a materialized view, compute the aggregation, the average now, and then just query the pre-computed values. Now,
this has an impact also from the point of view of speed as well, as in you obviously want your dashboards to continue to be super fast and snappy. So if you're constantly scanning data, it's going to be more expensive, but also it's going to be slower because over time it gets more and more and more data. And even though over a few, even up to hundreds of millions of rows, this is pretty fast. It's not the same. If you have a materialized view, it can be literally querying just a few hundred rows or a few thousand rows rather than a few million.
Yeah. The other interesting thing about materialized views in Tinybird is they are computed upon ingest incrementally. So there's no outside scheduler. You don't have to, schedule something that runs once a day and says, go and rematerialize this table. Every time you ingest a row, it triggers the materialization to go and update. But the update is done incrementally. So it works out what piece of the materialization is going to be affected by the new row and only updates the values that are affected by the new row rather than recomputing the entire thing. So again, like in reducing your stack, you don't need, Airflow or, some other scheduler to go and say, or dbt Cloud or something to go and run your materializations on a schedule. It's just done as you ingest, and you never have to worry about, hey, when did this materialization last run? So in the interest, I've just copied and pasted the SQL in. So all I'm doing is selecting the time and turning it into the start of the hour, and then grouping by the hour. So we're materializing it on an hourly granularity, and then computing the average of the forecast minus the actual to work out what the difference between the two values is, and then materializing that average per hour. So the results look like this. And then to create that as a materialized view, you can hit the little 3 dots next to the node, create materialized view from this node, and you get a little modal to go and set some config on that materialized view. So we can partition by the year. It doesn't particularly matter for this example. We'll be sorted on the hour. I will copy the name so I get the name right in there, and change that name, and that'll be fine as it is. So I can hit that, and then I get to choose what I want to populate the materialized view with. So if you've got loads and loads of data, you can choose, hey, I don't actually need like all of my data. I only, I can just pre-populate or seed my materialized view with up to 2 million rows. I can say do it with all previous data and new data, or don't go and seed it with anything, only do new data, or I can write some custom SQL and say, apply this to populate it with. So I'll say previous and new data and create that materialized view. So once you've created that, it appears as a new data source down on the left, and that'll go away and run a populate and start populating that with all my historical data. Now I actually want to publish some of the stats out of this materialized view. So I'm going to create another pipe, and instead of selecting from the raw data source, I'm going to select from the materialized view. Now this pipe has multiple nodes, so you'll get to see how we can chain nodes together. But in the interest of time, rather than dealing with typos that inevitably will happen, I'm just going to copy and paste it so that doesn't happen, because I'm going to miss a by or an as and get stuck. So again, this is a very similar query to before, and all I'm doing is I'm selecting from that materialized view. I'm taking the time, the hour, and then I am. This is a sort of a detail of the underlying database that we use, which is ClickHouse, where we have to merge the incremental states of the materialized view. We have blogs and guides that go into more detail about that. I won't spend too much time talking about that right now. But we get the average, and we merge those back down together. We get the time period. We have parameters to say a date range to and from, and then we group it by the hour. If I run that, it looks exactly like we had in the materialized view. So it's basically just seeing the results of the materialized view and adding the two where parameters. So this is our first node. I'm just going to call that node 1 for the time being, because I can't remember what I called it in this. I called it time series, so I'll call it time series. So this is getting my time series data. That's Tim series, not who Tim is. And then if I scroll down in the UI, we can actually start adding second nodes. So we said before that all of your APIs are pipes, and your pipes are composed of nodes, and nodes are individual select statements. So you can chain nodes together. So I can write this node, which contains my, selecting it from the materialized view and applying a filter. It gives me this result. But then in my next node, I could do a select, and I can select the results of the previous node. So I can break large queries down into multiple smaller composable queries, and then you don't end up with a 600-line piece of SQL that nobody understands, and in 2 years' time people are like, don't know what that is. So it just makes it slightly easier to work. So I'll quickly flip back over here and copy this one. So from my time series data, this is going to be my by hour data. So when a user comes and says, give me data between A and B, and that is just a 7-day or 7 or less days, I'm going to give them hourly granularity. So this node is going to select from my time series data and modify it and give them hourly granularity. So really the only change I'm doing is turning the diff value into a float 32 and putting a ceiling on it to put it to 1 decimal point. And my next node is going to be my daily granularity. So when a user comes and says, hey, I want 30 days worth of data, I'm not going to show them every single hour. I'm going to group it by day. So I'm going to use toDate and just say, hey, take these hours and turn them into just the start of the day, and then group it by the day. And when I run that, they'll get daily granularity. So I'll call this by day. And the only reason I'm doing this as separate nodes is because it just lets me logically break my query out, so that when somebody else comes to maintain or update this query, they can see, hey, look, I'm building my time series logic here, and then my logic to do it by hours here, and my logic to do it by day is here. It's just a nice way of organizing my logic. And then finally, I want to write my actual logic to expose this as an API. So I'll just paste that in. So again, I'm defining two parameters, which is the param2 and the param from. And then I'm doing a diff on the date to say, take these two dates, minus them from each other. And if the difference is less than 7, then I want to select the day and the diff from the by hour node, which is this node. But if the day difference is greater than 7, I want to select the results from the by day node. So all I'm doing is, like selecting the results from different nodes to say, give them that result or give them that result. And if they don't either, I'm just giving them the by day one just as a catch-all. So that's my API endpoint. If I can type, and I will turn, so I can see you can publish any of your nodes as the endpoint. For me, I want to publish the fourth one, the endpoint one. Publish that. And if I switch back over to my dashboard, have I messed up the API? Quite possibly. This is the problem with copying and pasting and going very quickly, because I've waffled on for too long and we've only got 5 minutes left.
Maybe you can try. Just setting them. What is the error? Actually, I can't see it.
Oh, because I didn't name it, so it's still 404.
Of course.
So I'm going to change the name.
There you go.
Ta-da.
Ta-da. Very good.
So now I get my time series, which is just showing me, was the forecast, how accurate was the forecast, what was the difference, and it's going to dynamically change how we aggregate the data based on the query parameters. Now, that's all of the APIs, and all I had left really was just to switch over to the terminal. It's always going to be that exciting bang on the data generator, which is going to start sending new data for December. So it's just going to hit the National Grid's API, get those buckets, generate synthetic data between the buckets, and ping that into Kafka. I don't need to do anything. So in Tinybird, it's connected, and it's going to start writing that new data into those topics, into those tables immediately. And then in my dashboard, I can turn this to month to date, and I'll start seeing that this has now gotten up to the 5th of December at the end there, and I can keep doing this, and now it's at 7th of December. So you can start to see that I'm not doing anything. I'm generating data from my Python, sending it to Kafka. It's automatically writing it into tables, and then every time I refresh this, it's hitting the API and getting whatever the latest data is. So it's up to the 10th now. And that is it. That's pretty much what I had to cover. Sandra, if you want to talk about observability, if you can fit that in.
Very quick. Do you want to just make me the sharer here?
Yeah. Do you want to start sharing your screen?
Yep. So I'm going to present. There you go. Can you see my screen? There you go.
Okay.
Magic. So I'm in the same workspace. As you can see, there's some people sharing here, and these is the data sources that Alistair has generated with the APIs and the endpoints and so on. But it's since we're ingesting data very quickly, I just wanted to make everybody aware that we have, you can see it if we go into any of the data sources here, you can see if you go to log, actually instead of a log, what you get is a query. And this query, what it's showing is the query over the data sources obs log, which is where we dump all the observability data about every single ingestion event that it's happening in your data sources. In this case, particularly for this one, the generation one. Is this where data is coming in right now? It is, right? So one thing that's really interesting is from here, you can go and create a pipe. I think if I do it from this screen, it'll use this query. There you go. And this data sources that start with Tinybird data source, Tinybird something, are the observability data sources, the service data sources. If you go to the documentation, you can find them here under monitoring, and you'll see there's a bunch of them. We have
you're only sharing You're only
Oh,
sharing one tab, so we can't see the documentation page.
all right. So let me do something really quickly. I'm just going to change this really quickly, and then I'll click back. But as you can see, you have a number of them about the pipes as well, about the BI connector, data sources, endpoint errors, and then the Kafka ops log. So I'm just going to quickly create an API endpoint here that just to show you how that look, because you can do a number of things here. So if I go to, I'm just going to copy and paste them. I have them here created. So for instance, if I do this, and I'm going to get just rid of this and just look at everything. So here, for instance, I can see per data source ID how many messages are being committed and how many, this is coming from the Kafka ops log, and how many bytes are being processed for each, for each topic per minute. So if I refresh this, you'll see that the numbers are changing as basically as the data comes in. So you can see that it's been ingesting over the last few minutes, and then until then there was data from previously. This is just one example of something you can do with the Kafka ops log. Another one would be if you wanted to analyze your lag, you would do something like this. So I'm going to select the topic, then the partition, and what is the average lag, because it can happen that one partition is generating problems, and you can then use this as a way to check what's going on here, and whether there are, like, for instance, this one has more lag, the intensity ones has more lag. This is probably because there's less data, so it's waiting for longer to sort of buffer the data. But just a quick way to see that you can quickly understand what's going on with the data using the observability data. And you can do this in real time, which you can use then for alerts. You can create an API endpoint and connect it to Grafana using you can find a guide on how to do that as well in our guides. And then if you look at the data sources ops log, I can also find all the sort of ingestion events that are happening with Kafka. In this case, I'm filtering by event append Kafka and result OK. And if I do this, what I'm getting here is the append Kafka's per data source, and what is the number of rows, the added number of rows in total that we've been adding, and the number of bytes, and order by date. So this is just a way to say, hey, I can have a very, very real-time idea of exactly what's going on with my data and my ingestion process. And you can do the same as well with the pipes. I don't have a specific query here, but just to give you a sense of how that looks, I can do pipe stats. You have pipe stats, which is aggregated and gives you a week of data, and pipe stats RT, which is real time, every single request, and what was for which pipe, what was the duration, how many bytes were read, how many rows were read, what was the URL, whether there was any errors or not. So you have all the information here, and our customers do all kinds of things with this, either watch it in Grafana or extract it and send it to Datadog, or you can take advantage of this data very easily.
Yeah, one interesting thing as well is you can see the name of the token in those requests. So people who are building other SaaS tools on top of Tinybird, for example, can start to work out, if their end customer has a token and is hitting APIs and they have a specific token, they can start to see which customers are hitting APIs, work out which request was which customer, and attribute API usage to individual customers, and start building usage analytics of their own customers by using this log. So it's quite interesting.
Absolutely. All right, so I think we can wrap up, Alistair, if you want.
Yeah, I've sent the link to the Grafana guide and a post about exporting it into Datadog as well into the chat for anyone that's interested in those. So just to wrap up quickly, we've seen how quickly we can integrate Kafka with Tinybird and then build REST APIs on top of the streaming data to get real-time access to our Kafka streams through APIs and power applications. We've also seen how we can use Tinybird to expose observability data and monitor that solution. The last point is really just that, you know, Tinybird is being used by a massive variety of people, from massive organizations, enterprises, through to you know, new startups and hobbyists. So the whole range of millions of events coming through Kafka to people sending it directly to Tinybird without Kafka at smaller data rates. So really, it's very flexible to scale with you, regardless of you know where you're at the moment. And it massively reduces the complexity of building data-driven backends, so that you can start to build over your data much faster and reduce the footprint of your tech stack. I quickly wanted to touch on ksqldb, because we did have that as part of the promo. We are over time, so but hey, we're on YouTube, so we can keep going. So ksqldb is an interesting one, and we often get asked, you know, how do we differ from ksqldb, and sort of how do we compete, or why would I use one over the other? So I just wanted to cover that, and just to say, like, it's not necessary that you only have to use one or the other. So we do have people who are using both and using them together quite successfully. So you know, ksqldb is running directly in Kafka over your stream. So it's great for doing stuff over your data while it's in flight. So we see folks often having great success with ksqldb, using it as a way to like manage your streams, while Tinybird is much better at actually asking questions over your data. So, for example, you know, people often use ksqldb for, say, filtering data from downstream systems. So we have a few customers on Tinybird who use ksqldb to filter what they send to Tinybird. So, you know, they don't necessarily need like 100% of one very high throughput stream to power their application. They may only need a segment of data from a stream in Tinybird to power an application, and so they use ksqldb to filter on that stream and say, hey, look, send this portion of event to Tinybird and send the rest over somewhere else. So that's one way you can use them together, and you know, that may be for performance optimization. You know, generally speaking, the less data you query, the less data you have to read to answer your question, the faster your queries will be. So when latency of asking questions is very important, it can be good to filter out that you don't actually need to answer that question. So that's I mean, just one way that people are using ksqldb. Now, obviously, it's not the only way to do it, and you know, you can use materialized views in Tinybird to do that kind of filtering as well. So if you do want to send the whole stream into Tinybird, you can use materialized views and then segregate that data into different data sources. And people, you know, the reason you might do it in Tinybird and not in ksqldb is if, for example, you may not need the data now, but you might want it in the future, or you've got a stream that has two different types of events in it, and you've got one set of questions for one segment of data and another set of questions for another segment of data. You might use Tinybird to separate those and then build your questions separately, in which case you do want to segment the data, but you actually want all of it in Tinybird anyway. So that's very briefly on ksqldb, because I don't want to go on too long. But that's everything I have to cover anyway.
While you were talking, I was just building a visualization here with the time series tool just to also going back to observability. You can use this as well to understand what's going on with appends and so on, or you can also use it to explore your own data. So we could look at the same data source that we've been creating here as well. All right.
Lovely stuff. All right. Well, I think we're done. I hope we covered everything.
Maybe too much.
People found that useful. Yeah, I didn't. I thought that was going to be a lot quicker, and we were going to get through that, and I didn't expect to have to rush. But hopefully, it still made sense even despite the rush. So anyway, thank you to everyone that came, and the recording of. At least I hope we recorded this, and there will be a recording. So if you didn't make it live, thank you for watching, and have a good New Year, everyone.
Yeah, thank you, and Happy New Year, everyone.